Hello, I'm here to discuss some exciting ideas for building the next generation of cities on Mars. Mars is a red planet with a large amount of iron oxide on the surface. Its thin atmosphere is mainly composed of carbon dioxide, and it's challenging to resist the radiation from the sun and cosmic rays. It also means that there is a considerable temperature difference in a day. Besides, there is no stable liquid water. If we want to make Mars more livable, it should be able to provide its inhabitants with basic needs, building the required infrastructure, providing continuous oxygen, finding safe and viable water sources, addressing a constant food supply, and more. To achieve this, we propose several bio-inspiration and biorobotics solutions. The first idea is to use a fleet of drones with 3D printing and a path planning framework to construct buildings. This is inspired by the way bees and wasps building their nests. The solution could help construct and repair various geometry buildings. It helps reduce the cost and risk. The shelter employs a unique dual-shell scheme to isolate the habitable spaces from extreme temperatures. Indirect natural light from the skylight and intermittent windows flood the interior, while providing humans from harmful solar and cosmic radiation. The recyclable polymer composites outperform concrete in strength, durability, and crash testing in freeze-thaw conditions. On the shelter's top floor, I suggest creating a greenhouse to generate food on Mars. In addition to water, some primary conditions on Mars can satisfy the growth of plants. I will discuss how to sow, pollinate, and harvest with robotic assistance. A natural seed has inspired the design of a robot that can bury itself in soil when exposed to rain. The mechanism relies on the shape-changing properties of wood, and the material is natural and renewable, allowing for harmless degradation from robot after use. This robot improves germination efficiency. Superior to the natural seed, this robot is equipped with a soft actuator made of light-responsive liquid crystalline elastomer, which induces opening or closing actions of the bristle upon visible light excitation. The robot carries pollen, disperses with winds, and is directed by light. It has a stable separated vortex ring generation to enable long-distance wind-assisted traveling. This is a robot with a compliant gripper inspired by the structure and mechanics of the tassel chain. The N effector with non-rigid materials improves grasping ability and passively adapts to the irregular shape of products. The integration of image recognition and location technology would also improve the accuracy of harvesting. Oxygen production on Mars can not only rely on plant breeding, I also introduce another way. Below the terrestrial surface of Mars is ice. I suggest using Parsec to collect water. The robot drills a hole through the rocky layer. The melting tool can insert and rotate in the ice to create melted water. The water is full of magnesium perchlorate. A perchlorate brine electrolysis approach provides a unique pathway to hydrogen fuel and life support oxygen on Mars. For drinking, water with perchlorate goes through desalination to remove it. Homesickness, loneliness, and resource constraints on Mars are the perfect environment for depression. To this end, psychological health profiling and treatment should be undertaken. Multi-level living spaces designed around human needs are also beneficial to sustain social and mental health. Due to the differences in cultural systems, cooperation could become challenging. The potential for crime brought by the struggle for existence and mental tiredness would also increase. The issue should be mitigated in advance by constructing a shared value system, law, and penalty system. In conclusion, these bioinspiration and biorobotics solutions are innovative and practical. They offer a sustainable way to support human life on Mars while minimizing risks on humans and the Martian environment. Thank you for your time.